All right, so the last thing we want to do here with these washers and discs is looking at taking a region and revolving it about something other than the x or the y axis. So, in other words, we're going to be looking at revolving about some other vertical line. And we're going to be looking at revolving about some other vertical line. That's going to be our idea. It's not going to be about some slanted line that makes things way too complicated, but rather just revolving about some other either horizontal or vertical line. Okay, so we can generate some other shapes, by doing it this way. Okay, so in this example here, we have the equation y equals 1 minus square root of x, and we're looking at the region bounded by that, the line x equals 1, and the line y equals 1. So I've gone ahead and hopped on the Desmos and graphed that so that we have this kind of weird looking slice of pizza type thing. But this slice of pizza is not being revolved about the x, nor is it being revolved about the y. It's instead being revolved about the line y equals, or x equals 1. So what we have to do is try to look at our measurements, how our measurements would look. If we're taking this pie shape and revolving about my green line here, then notice that's actually touching it. So I don't need washers. I can get by with the disc. So we'll have to measure our radius with respect to the axis we're revolving about. So this is going to be a horizontal sliver. That means that we're going to have to integrate with respect to y. We can see the region runs from y equals 0 to y equals 1. So we can see that. So first thing I'm going to have to do is take that graph y equals 1 minus square root of x, and I need to convert that over as a function of y. So we do that. Y equals 1 minus square root of x. Bring the square root over, flip-flop it with the y. X equals 1 minus y. So square both sides. X would be equal to 1 minus y squared. Okay. So x would be equal to 1 minus 2y plus y squared. Now, that's the function now expressed as a function of y. And if we were revolving about the y, then we could use that. And we'd actually, if we were revolving about the y, hopefully you can see you'd have an outer function of 1 and an inner function of that. But we're no longer revolving about y, we're revolving about the line x equals 1. Okay, so what we need to now do is realize what is this actual length in terms of x, or in terms of y. So, because it's just this radial length, the distance between x equals 1 and the graph. Well, that would just be the difference between 1 and whatever our x value is. That would give us our radius. Now we know x is given by this. So the radius is just going to be 1 minus x. Which would be 1 minus 2y plus y squared. And that would simplify to be 2y minus y squared. Right, that will be my radius. And so now we're ready to compute the volume, just using the same idea of a disk, because it is touching the axis. So it's just going to be pi times our function squared, okay, which this is going to be our function now, and it's going to range from 0 to 1 as we do the integral. So integral from 0 to 1 of pi times the radius squared, 2y minus y squared, dy. Okay, and then we keep going. Integral 0 to 1, roll the pi out front. Inside here, squaring that would be 4y squared. And in the middle, we're going to have minus 4y cubed plus y to the 4th dy. And then we work this out. Do our integral for 4y squared. When you do the integral, that'll be 4/3 y cubed minus y to the 4th plus y to the 5th over 5. And that's all evaluated between 0 and 1. And so then we do that computation. Plug in 1, you're going to have 4/3 minus 1 plus 1/5. Plug in 0, it's all going to be gone. When we simplify that computation, we will have 8 over 15 pi. The volume of this solid here is 8 over 15 pi.